Okay guys, next topic, the converse of the Pythagorean theorem. And the converse of the Pythagorean theorem kind of looks like an if-then statement, something you had back in the first couple of chapters at the very beginning of the year. So let's see what this converse is. Let's say we have a triangle. This is triangle ABC, the capital letters being how we name the triangle, and some smaller lowercase letters that are our side lengths. So if the sum of the squares of the lengths of the shortest sides of a triangle. Okay? Remember, our given here is this looks like a right triangle, but we're not sure. So the shortest side lengths are A and B. If we square each of those and add them together, if that is equal to the square of the length of the longest side, okay, in this case C is our longest side, if that is equal to the square of that, then the triangle is a right triangle. Okay? That's a very long, very wordy definition. Let's break it down into some algebra. Simply we're saying this: if a squared plus b squared equals c squared, the Pythagorean theorem, a and b are the smallest two side lengths, this is the biggest. If that is true, we plug in the numbers and that's true, then triangle ABC, or whatever triangle we name it, is a right triangle. Okay? That's the converse of the Pythagorean theorem. The first Pythagorean theorem said if we have a right triangle, then this is true. Okay? The converse says if this is true, then it's a right triangle. Let's do a couple practice problems here. All right. Here we have triangle DEF with side lengths of 15, 36, and 39. And we want to see, is DEF a right triangle? Notice we have no angle measurements marked there. We don't know for sure it's a right triangle. So we test it using the Pythagorean theorem. So our shortest two lengths are 15 and 36. So we're going to set this up and say 15 squared plus 36 squared. We're going to see if that is equal to or not equal to 39 squared. All right, 15 squared, you can punch it into your calculator, gives you 225. 36 squared gives you 1,296. 39 squared is 1,521. Yes, I did them ahead of time. I can't do those in my head. So 225 plus 1,296 is 1,521. And that is equal to 1,521. Since they're equal, yes. Triangle DEF is a right triangle. Okay? All right, let's look at one more example. All right. In this case, we're not given a picture. We're just told, does a triangle with lengths of 8, 25, and 24 form a right triangle? One reason I want to go through this, two reasons really. Number one is just a different way to look at the problem. The other thing is get very careful that you always do, that you're adding together the squares of the two shortest lengths, saying it equal to the largest. Don't just go 8 squared plus 25 squared equals 24 squared. You could get the wrong answer. The two shortest lengths are 8 and 24. Those are the two we're going to square and add together. So we test it out. 8 squared plus 24 squared. And we're going to compare that and see how that compares to 25 squared. 8 squared is 64. 24 squared is 576. And 25 squared is 625. Okay, and again, just do it with your calculator. So we can add these two up. 64 plus 576 is 640. And we can see right away that is not equal to 625. Therefore, no, this is not a right triangle. Now, we're going to find out in the next section, or next two sections, I believe, that we're actually told something more here. The fact that this number is larger than this actually doesn't just tell us that it's not a right triangle. It can help tell us whether it's acute or obtuse. Work the practice problems, and we'll see you in the next video.